Hello students, in the last class we studied the characteristics of particles of matter and different states of matter. Today we are going to study the change of state of matter. The change of state of matter. Matter can be changed from one form to another. This can be possible by changing the temperature and by changing pressure. First we are going to study the change of state of matter by changing temperature. By changing temperature. You know that water exists in three different states. That is ice, water and water vapor. How you get water from ice? Ice is the solid form of water. When you heat ice, when the temperature is increased, ice gets converted to water, and when you heat water, we get water vapor. So same way, by changing temperature, any solid substance can be converted. By increasing temperature, any solid substance can be converted to liquid, or liquid can be converted to gas. Or by decreasing temperature, gas to liquid and liquid to solid. So we can understand this with the help of an activity. Take about 150 gram of ice in a beaker. Keep a thermometer in the beaker such that the bulb of the thermometer be in touch with the ice. Then heat the beaker with the help of a burner in low flame. When you heat it, the ice will melt. And when the ice starts melting, you note the temperature shown by the thermometer. And this temperature is called by the name the melting point. So it is the melting point. And you know that the thermometer will show a temperature of 0 degree Celsius. That is 0 degree Celsius is the melting point of ice. Then what is melting point? The temperature at which a solid substance converts to liquid state at the atmospheric pressure. That is called melting point. The melting point of ice 0 degree Celsius. Otherwise, when you convert it in Kelvin, 273.16 Kelvin, because you know that 0 degree Celsius is equal to 273.16 Kelvin, and when you write, we are not considering this 0.16, we directly write 273, and if you want to convert any degree Celsius to Kelvin, add 273.16 then. So what is melting point then? The temperature at which a solid substance converts to liquids. It is called as the melting point. Now, and this phenomenon, it is known by the name fusion. It is called as fusion. That is the melting. It is known by the name fusion. So, what I told you, heat the ice which is taken in the beaker and note the temperature. When the ice starts melting, the temperature shown by the thermometer will be 0 degree Celsius. Again, you continue heating and observe the thermometer. We can see that there will not be any change in the reading shown by the thermometer until all the ice gets converted to water. And when this water, when it starts boiling, then again you note the temperature shown by the thermometer. And that will be 100 degree Celsius. 100 degree Celsius or 373 Kelvin or 0.16 Kelvin. Then this temperature at which the liquid substance starts boiling is called by the name boiling point. It is called as boiling point. Then what is boiling point? The temperature at which a liquid starts boiling at atmospheric pressure. It is called as boiling point. So the boiling point of water 100 degree Celsius. And this phenomenon is called as boiling. Phenomenon is called as boiling. Then. And again you note the temperature. and the temperature remains at 100 degrees Celsius until all the water gets converted to gas or water vapor. Then where this heat has gone? Here also we are continuously heating, and in this here we see the heat that we have provided. It is used for converting the ice to water or from changing the solid state to liquid state. How to convert from solid to liquid? Because you know that in solid the particles are packed, the molecules are packed. There is no intermolecular force. There is no intermolecular space, or the intermolecular force, it is the maximum in solids. There is no intermolecular space between the particles in solids. And when you heat, the heat which is provided, it is used by the solid particles to break up this intermolecular force, and they gets converted to liquids. And when you heat, and this heat which is absorbed by the solid, it is known by the name latent heat of fusion. So what is called latent heat of fusion, and this heat is called the latent heat of fusion. So what is meant by the latent heat of fusion? The amount of heat required to convert 1 kilogram of solid to liquid state. This is called by the name latent heat of fusion. What is latent heat of fusion? The amount of heat required by 1 kilogram of solid to convert to liquid state, it is called latent heat of fusion. Then understood why the temperature has not increased there. Again, when you heat, when the water starts boiling, till all the water gets converted to water vapor, the temperature remains at 100 degrees Celsius. Here where the heat that we have supplied, it has gone. Same way here also the heat is used for converting the water to water vapor or from liquid to gaseous state. And this heat required by 1 kilogram of liquid to convert to gaseous state, it is known by the name latent heat of vaporization. Latent heat of vaporization. So is that clear? So once again, change of state of matter. State of matter can be changed by changing the temperature and also by changing the pressure. Here we are going to study how the state can be changed by changing the temperature. For that, one activity I told, take about 150 gram of ice in a beaker. Keep a thermometer into that beaker so that the bulb of the thermometer be in touch with the ice. Then heat it with the help of a burner. Then note the temperature shown by the thermometer. When the ice starts melting, the thermometer shows a reading of 0 degrees Celsius, and this is called the melting point of ice, and this process is called as fusion. And what is the melting point? The temperature at which a solid substance starts converting to liquid, converts to liquid at its atmospheric pressure, is called the melting point. And this phenomenon at which a solid substance converts to liquid is called, at its melting point, is called fusion. The melting point of ice, it is 0 degrees Celsius. Then again when you heat it, the water starts boiling, and the temperature at which the liquid or the water starts boiling, it is called as the boiling point. Here as it is water, the boiling point of water 100 degrees Celsius, or in Kelvin 373 Kelvin. And this phenomenon is called boiling. And here also, till all the water gets converted to water vapor, the temperature remains steady at 100 degrees Celsius. Now, even though we are providing heat, the thermometer reading is not increased, or it is not changed until all the ice gets converted to water or all the water gets converted to water vapor. In the first case, in the case of ice, then where this heat has gone? The heat is used by the ice to convert it into liquid by increasing the space between the molecules, or by breaking the intermolecular, or to break the intermolecular force of attraction. And this heat, the amount of heat required to convert 1 kilogram of solid to liquid state is called by the name latent heat of fusion. Same way, the amount of heat required to convert 1 kilogram of liquid to its gaseous state is known by the name latent heat of vaporization. Is that clear? Then, and there are certain substances. Here in this, what we are seeing, when solid is heated, it gets converted to liquid, and when liquid heated, gets converted to gas. But you know, there are certain substances that goes directly into the gaseous state without entering the liquid state. There are certain solid substances that directly go to the gaseous state without entering this liquid state. And this phenomenon is called by the name sublimation. It is called by the name sublimation. Sublimation. It is called as sublimation. And such substances that converts directly to gaseous state without entering the liquid state is called sublimable substances. Sublimable substances. Examples for this substance. Can you tell me one example? Camphor. Yes. Camphor is an example of a sublimable substance. Then naphthalene balls. You must have seen naphthalene balls. Naphthalene balls. Another examples. And then ammonium chloride. All these substances, when you heat, they directly enter into the gaseous state. Then what is sublimation? It's a phenomenon in which a substance directly enters the gaseous state without entering the liquid state. I think all these topics clear to you about change of state of matter by changing the temperature. So the next, the state of matter can be changed by changing its pressure. How is it? We can see. Second one, change of pressure. Change of pressure. You must have seen the LPG cylinder, isn't it? What is LPG? So liquefied petroleum gas or the liquid petroleum gas. How the gas is filled in the cylinder? You know, when the gas, when it is compressed under high pressure, the gas gets converted to liquid. Because gas, you know that the molecules are far apart. They are very free to move. But when it is compressed, what happens? The distance between the molecules are reduced and they get converted to liquid. And when it is compressed and it is filled in the cylinder. So that is LPG. Again, even CNG also, compressed natural gas. That means when gas is compressed under high pressure, it gets converted to liquid. Same way, another example. Have you heard of dry ice? Solid carbon dioxide. Carbon dioxide, solid carbon dioxide. What is solid carbon dioxide, or what is dry ice? Solid carbon dioxide is called dry ice. That is carbon dioxide gas stored under high pressure. Carbon dioxide gas stored under high pressure. You know, it goes directly to the solid state. That is what it is called by the name dry ice. Carbon dioxide gas which is stored under high pressure. It is dry ice. So that's all about the change of state of matter by changing the pressure. Okay, now the next topic in this, evaporation. The next topic it is evaporation. in evaporation. What is evaporation? You must have seen when you put wet clothes outside, it gets dried up. And do you think always we have to heat any object to convert from solid to convert from the liquid to gaseous state? Is it necessary always we have to heat? One activity, one example I'll tell you. Take some water, keep it in a vessel undisturbed. After a few hours or after one day also, after a few hours, you just see the level of water which is taken in the vessel. We can see the level of water, it is decreased or it is reduced. What is the reason? Where the water has gone? You know, the water gets vaporized. Here we are not done any heating. We are not done any heating to this water which is kept in the vessel. Then also this liquid or this water gets converted to vapor. And you know, this process, this phenomenon is called by the name, evaporation. Then what is evaporation? It is the process of conversion of a liquid to gaseous state at any temperature below its boiling point, and that is called as evaporation. The best example I told you, wet clothes. When you keep it outside, after a few hours we get it dried. That's an example of evaporation, because water from the wet clothes, it gets evaporated, converted to vapor. And there are certain factors that affect evaporation. And before that, it will be boiling and evaporation. What is the difference? Boiling, I told you, it's a certain temperature. For example, for water, the water boils or gets converted to water vapor at what temperature? 100 degrees Celsius. But for evaporation, it can be any temperature below the boiling or below 100 degrees Celsius. That is evaporation. We have seen in boiling, it's a bulk phenomenon, but evaporation, it's a surface phenomenon. And boiling, you know that it's a fast process, but evaporation, it's very slow. But we can see which are the factors that affect evaporation. Factors affecting evaporation. The first one, surface area. How surface area affects the rate of evaporation? The starting I told you in the example, water which is taken in a vessel. The same water you take in a glass and in a plate. In which case the surface area is more? Definitely it's in the plate only. Keep both the water undisturbed for some hours and afterwards you observe it. We can see the evaporation becomes faster in which the water is taken in the plate. The plate where the water is kept, the evaporation is faster than the water which is taken in the glass. Why? The surface area is more. And second factor, temperature. Here, first point, surface area. So what's your conclusion from that? As the surface area increases, evaporation also becomes faster. And next, what about the temperature? As the temperature increases, the evaporation is faster. The rate of evaporation will be fast. Because the atmospheric temperature, if it is more, that means in the summer, the temperature is more. We can see the even the wet clothes, they get dried up very fast. So as the temperature increases, evaporation rate also increases. And the third, it is humidity. What is humidity? What is humidity? The amount of water vapor which is present in the atmosphere, it is called by the name humidity. So what is humidity? The amount of water vapor which is present in the atmosphere. What is the effect of humidity on evaporation or rate of evaporation? You know, as the amount of water vapor in the atmosphere, if it is more, the rate of evaporation will be slow. Means as the amount of water vapor increases, evaporation decreases. The rate of evaporation decreases. Then the next point, it is wind speed. Wind. Can you tell me what's the effect of wind on evaporation? Same thing. In the case of wet clothes, when you keep it outside, if there is wind, the clothes gets dried up very fast. So that means evaporation becomes faster due to wind. So these are the four factors that affect evaporation. Which are they? The surface area. As more surface area, evaporation will be more faster. Then for the rate of evaporation is more. And temperature. As the temperature increases, evaporation also increases. Humidity. As humidity is more, the rate of evaporation will be less. Then if there is wind, due to the effect of wind, the evaporation rate will be high. So these are the four factors that affect evaporation. And you know, evaporation causes cooling. Evaporation causes cooling. One example, can you tell me? You know acetone, that is a nail polish remover. If you put it in your hand, you feel cold. What is it? What is the reason for that? What is the reason? Because, and another example I'll tell you. We prefer cotton clothes. During this, all I'll give you, find out the reason and give it to me. That's cotton clothes during summer. Third one, during summer season. And you must have heard that people, they sprinkle water on the terrace and all. Or otherwise in the room only, in the floors also they sprinkle water. What is the reason? The main reason, the point I have given, we can elaborate it. What is it? Evaporation causes cooling. So find out the reason, and these three statements or the questions I put, find out the reason and write it in your book. And more assignment questions I'll give you for this chapter. What we have learned, first question that you have to answer, define melting point. I only dictate the question, you can note down. Define melting point. Second one, define fusion. Third question, define boiling point. Define boiling point. Define boiling. What do you mean by evaporation? And what are the factors that affect evaporation? What do you mean by evaporation and what are the factors that affect evaporation? Then already 3 questions I gave you to find out the reasons. Okay, but the explanation is there in your textbook also, but then also write it in your own words. Then difference between. Try to find out, already 3 differences I told. Try to find out 4 differences between boiling and evaporation. So try to find out answers of these questions and write it in your notebook. Now there are in-text questions and exercise questions that I will send you afterwards. Okay, I think today's topics, it's clear to you. Read the textbook and try to answer the questions. Thank you. ஆமாம்